Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video we're going to be looking at word problems that have to do with motion and mixture. So we're going to start off with motion. And before we go into an examples, I just want to go over what you usually would look at in terms of formulas. Now, anytime you think about motion, you're thinking about speed. Now, speed, we know, if I told you, how fast are you driving outside? Well, you'd be telling me 20 kilometers per hour, 30 kilometers per hour, or if you're on the highway, maybe like 100 kilometers per hour. Each one of those usually has kilometers, hour, which means you're always looking at what? Distance divided by time. So that's the actual formula for speed. Speed is always going to be distance divided by time. Now, we can always find the other two types of formulas. What if I wanted to solve for time or distance? Well, let's say I want to solve for time. Well, for time, I would have had to take this t and bring it up here, and then divide both sides by speed. So, overall, I would have distance divided by speed. And finally, what if I want to solve for distance? Well, to solve for distance, for one thing, you'd have to get it by itself. And how do you do that? By multiplying both sides by t to get rid of your denominator. Once you've done that, it's completely by itself. So what ends up happening? You'd have speed times time. So these are your three major speed and motion formulas. Let's see how we use them. So let's look at this example. So we have here a bus leaves a station traveling. And remember, you always want to try to use your underlining method from before when you're looking at word problems. So a bus station not a bus station, a bus leaves a station traveling, I can't talk today, 50 kilometers per hour. I think this is very important. A car traveling 60 kilometers per hour leaves the same station. I think that's also important. Same station. 3 hours later. That's very important too. 3 hours later. How long will it take? So long. How long will it take the car to overtake the bus? So whenever you want to do these type of word problems, the first thing you want to do, well, we just did it. Underline keywords. The second thing you want to do is, it's always very helpful to make a table to display your given data. Now, this table is going to be in two parts because there's two parts of this problem. And you're going to find that for all motion and mixture problems, there's always going to be two parts. So what would my two parts be? So let's draw this. So first and foremost, we're talking about a bus, and then we're talking about a car. Now, this is also a motion problem. And because it's a motion problem, as you saw on the last page, what are my variables usually? My variables usually have to center around my distance, my speed, or you can also call it the rate, so remember, all speeds are basically slope. And finally, what's the last thing missing? My time. Okay. Now, let's look at what we're given here. So, I have this thing here where it says I am leaving at 50 kilometers per hour, and da 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 da. So I know their speeds. I know the bus moves at 50 kilometers per hour. And I know the car moves at 60 kilometers per hour. Do I know how much time it will take for my car to overtake the bus? No. Do I even know how much time my car is traveling for? No. So let's make a variable here. And you know, in every single time you're making a word problem, you want to make a variable. So you want to say let x represent, and you usually want to make it represent your unknown. So in this case, my unknown is how long it will take for the car to overtake the bus. Okay, so let's put that there. So my time should be x here. And then, so what should my time then be for my bus? Well, I know that the bus has been going for about 3 hours more than my car. So if my car is x, the bus has been traveling for 3 hours more. More meaning plus. So I have my speed, I have my time. Now for distance, remember, it's supposed to be, remember those formulas from the first page, speed times time. So essentially what you're going to be doing is you're going to be multiplying these two columns. See how the table helps actually really nicely. So basically for my bus, it should be 50 times x plus 3. For my car, it should be 60 times x. So what do we have here? So we know that they catch up. So when they catch up to each other, that basically means that their distances should be the same. Because that's what happens when they overtake each other. So they overtake, that means at that point their distance has to be the same at some point. So we're finding the intersection, which means I'd write down 50 times x plus 3 should be equal to 60 times x. Because their distances at that point should be the same. So at this point, it's just a standard distribution question. Gonna distribute, Pokemon Go it. So 50 times x, 50x, plus 50 times 3 is 150, which will give you 60x. Let's get our x's together. So I'm going to move this 50x to the other side, and because it's already positive, that means you're going to be subtracting from both sides 50x. So you're going to have 150 is equal to 60x minus 50x should be 10x. Divide both sides by 10. So therefore, x is 15. So, what was my x again? My x was the amount of time, which means this would be hours. And of course, this is a word problem, so you want to make sure you have a nice final statement. So therefore, it will take 15 hours to catch up. And that's it. That's exactly how you do it. And I realized I just did not actually update my steps there. So what did we do after we made our table? Your third step is to make equal the two parts. And that usually works in every single case. So let's see how this works in another example. Okay, so I want you guys to try this one out. So pause it before and then come back. All right, I assume you're back. So let's do our steps. So Shelley leaves on a train traveling 45 kilometers per hour. Okay, that's very important. Her husband, Jack, leaves 1 hour later in a car traveling 70 kilometers per hour. Okay. How long will it take the car to overtake the train? Okay. So once again, you have a how long question. Now, obviously, I can always give you many different types of questions, like when you're looking for how much, how far away were they when they both met with each other, or find the speed, how fast must they go before they meet up with each other. So these are all different cases where you would make your two sides of the equation equal. So in this case here, it says how long. So long, this means time. The second I see long, it's time. All the time. Pun. All right, so we underline our words. We want to make our table. Remember, this table is going to have two parts. Just like in this question. This question, we have two parts. There's a train. There's a car. Now, of course, we're talking about motion again. So because we're talking about motion, there's going to be the three different parts. You've got distance. I'm not going to fully write out D. You've got speed. And you've got time. Okay. So we know our speeds already. Our speeds are 45 kilometers per hour for the train. And we got 70 kilometers per hour for the car. We also know the timings somewhat. So remember, you always want to make a variable. So let's let x represent. You can always use the arrow for represent rather than writing represent every time. Let's let represent the amount of time needed to overtake the train. Okay. Now you can make x represent anything you want. I mean, you can also make it represent how long the train was traveling for, or how long the car was traveling for. It doesn't really matter. You just need to make sure you make x represent something. And it's very important you write down this representation statement, because without it, x would not mean anything. All right. So, time. Again, my car's x, and my train was traveling for an hour earlier than the car, so x plus 1. That, once again, distance we know is speed times time, so my distance should be 45 times x plus 1, and 70x, essentially. So, we know the word, they said overtake, which means we want when they both have the same distance, because obviously if they have the same distance, they've met each other, and then they're about to overtake. So, once again, just like the last problem, you're going to have 45, x plus 1 is equal to 70x. Let's distribute this out. 45x plus 45 is equal to 70x. Let's get our x's to the same side. So you're going to have 45 is equal to 70 minus 45. So what do we have? 70 minus 45 should be 25. And finally, divide both sides by 25. That should give you 1.8. Now, 1.8 what? This is time, right? So, hours. Write yourself a final statement. So, therefore, it takes the car 1.8 hours to catch up and overtake, however you wish to say it. So, there's many different types of motion problems you would get, but they can all be solved this way with your table. So let's take a look at a mixture problem. Okay, so with mixture problems, it's always nice to illustrate this a little bit, but we're also going to still underliningly use a table. So we're still going to be using the same steps. So I'll write those steps again. So 1, underline keywords. So let's do that. So how many ounces of 30% acid should be mixed with 40 ounces, so 40 ounces, that's very important, of 2% acid to obtain 12% solution? So what does this mean? Let's draw this out actually a little bit, and let's see what this actually means here. So let's say this is my beaker. So let's say in this beaker right now, I have already 40 ounces of acid, of 2% acid. So let's say this is my beaker, I got 40%, and this is 40 ounces at 2%. And they're going to be adding to it. We don't know. So I don't actually know how many ounces they're adding to it, but I do know that it's 30%. Okay? What I do know, though, is that when they are added together, I make it now 12%. Okay? So that's a nice illustration of the situation. So let's continue on here. All right, so basically it's always going to be these two columns. And they multiply each other to give you this column. Okay, so that's going to give me 0.3x, 0.02 times 40, 0.12 times 40 plus x. So our third step, we want to set up an equation. Set up an equality equation. So what kind of equality equation would I have here? Well, I know by looking at my diagram that my end goal is getting 12% acid solution. So 12% acid solution, well, what is that? 12% acid solution. I'm going to have this much. So let's take that and put it. So 0.12, 40 plus x, should be equal to the 30% solution, as you can see here, the 30% solution, added to my 2% solution. So once again, I'm just going to be taking this column here, essentially. So that's going to be what? Let's do, well, not that column, actually, it's this column, but yeah. So you're going to get 0.3x plus 0.02 times 40 is just going to give you what? What's 0.02 times 40? Let's calculate that. That's 0.8. So, okay. So let's expand and simplify. All right, so let's do this. So 0.02 has to multiply by these two. Let's get into it. That's going to give us 0.12 x plus 4.8 is equal to 0.3x plus 0.8. So you want to get your x's together. So let's move the 0.3x to the other side, and we'll move the 4.8 to this side. All right. So let's continue. All right, so basically it's always going to be these two columns. And they multiply each other to give you this column. Okay, so that's going to give me 0.3x, 0.02 times 40, 0.12 times 40 plus x. So our third step, we want to set up an equation. Set up an equality equation. So what kind of equality equation would I have here? Well, I know by looking at my diagram that my end goal is getting 12% acid solution. So 12% acid solution, well, what is that? 12% acid solution. I'm going to have this much. So let's take that and put it. So 0.12, 40 plus x, should be equal to the 30% solution, as you can see here, the 30% solution, added to my 2% solution. So once again, I'm just going to be taking this column here, essentially. So that's going to be what? Let's do, well, not that column, actually, it's this column, but yeah. So you're going to get 0.3x plus 0.02 times 40 is just going to give you what? What's 0.02 times 40? Let's calculate that. That's 0.8. So, okay. So let's expand and simplify. All right, so let's do this. So 0.02 has to multiply by these two. Let's get into it. That's going to give us 0.12 x plus 4.8 is equal to 0.3x plus 0.8. So you want to get your x's together. So let's move the 0.3x to the other side, and we'll move the 4.8 to this side. All right. So let's continue. So when I do that, I'm going to subtract them. That should give me negative, whoops, writing with the arrow, negative 0.18x is equal to 0.8 minus 4.8, which is going to give me negative 4. Divide both sides by negative 0.18, which should give you 22.2. Now, once again, what was my x? The x was the number of ounces. So, what's my final solution? My final solution is 22.2 ounces of 30%. So make sure you write yourself a final statement as well there. I would, but I have no room here. So let's look at the next one. Okay, so let's take a look at this other example here. So, how many pounds of cashews, which sell at $1.50 per pound, should be mixed with peanuts, which sell at 25 cents per pound, to produce 40 pounds in total that sell for $1 per pound? All right, so I want you to pause it and try it yourself first. Okay, welcome back. So let's look at what's important here. So it says, how many pounds of cashews? It doesn't actually tell me how many there are, so I assume that's going to be my x, which sell at $1.50 per pound, should be mixed with peanuts, which sell at 25 cents per pound, to produce 40 pounds in total that sell for $1 per pound. All right, so let's set up our table. So what do I got here? I've got cashews, I've got peanuts, and I've got total. All right, so when we set up our table, remember, you're always going to have 3 columns. So what should my 3 columns be? Well, you're always going to be involved with a weight in these types of problems. Do I know how much weight my cashews are? No. So let's let X represent the number of pounds of cashews. All right. I do know that in total I have 40 pounds, which means whatever's left over of 40 minus X should give me my peanuts. All right. Next thing, what do we always care about as well? How much is it going to cost me? Well, how do I get there? First and foremost, what's the price per pound? Price per pound. Well, this is already given to me in the problem. Price per pound. I know this is going to be $1.50. I know that this is going to be where are you? 25 cents. Yep, 25 cents per pound. And lastly, I know in total it's going to cost me $1. Now, this is where people often mess up. They would add up $1.50 with 25 cents, and they say, well, in total it should cost me $1.75. That's not how weights work. They're just not going to add those 2 weights together, because obviously you may have more weight of one of them than the other, which affects your pricing. And finally, at the end, just like before, to get my last column, you're always going to be multiplying these 2 columns to get this one. And what do you think the last one's going to be? Cost. How much is it going to cost me? And to do that, you're going to multiply these 2. So that's going to give me $1.50 X. Okay, let's actually distribute from now. So 40 times 0.25 should give me 10 minus 0.25x. And 40 times 1 is just 40. All right, so let's set up my formula. So obviously in total, it's always going to be 40. When I add these 2 things together, they're going to give me $40. So what 2 things am I adding together? These 2 things. So $1.50 times X plus 10 minus 0.25x. All right, so let's collect our like terms. So $1.50 minus 0.25 should give me $1.25. Plus 10 is equal to 40. Let's bring that 10 to the other side. So it's going to give me 30. And let's divide out. So 30 divided by $1.25 will give me 24. So I need 24 pounds of cashews. So how many peanuts would I need? Well, 40 minus 24. What do you get? You'll get 16. So I need 16 pounds here, 24 pounds here, and you make yourself a final statement, and you are done. All right, so that is motion and mixture. Yes, a very long lesson, but I hope that you understood the methods and concepts from this lesson. Have a great day.